Welcome to my online course in Linear Algebra for undergraduate mathematics. In this lecture, we are going to discuss about Bessel's inequality. If W1, W2, Wn is an orthonormal set in an inner product space X, then the following inequality holds. That is, orthonormal set means the inner product of Wi, Wj is equal to 0 for all I not equal to 0. For all I not equal to j, and inner product of Wi is Wi with Wi is my norm of Wi square, and it is equal to 1. If W1, W2, Wn satisfy this condition, then in an inner product space X, then following inequality hold, and this inequality is known as Bessel's inequality. Proof. We consider X equal to V minus sum over I ranges from 1 to M inner product of V, Wi. Put this equation 1, then take the inner product of X with Wj, then inner product of this element with Wj. On expansion, I will get in the right hand side inner product of V, Wj minus inner product of sum over I ranges from 1 to M inner product of V, Wi, Wj. If I expand this element, second term in the right hand side, then when I take the value of 1, my first term will be V W1 W1 Wj, and second term will be V W2 W2 Wj plus at some point I will take the value of j. At that point our inner product will be V Wj Wj Wj. Okay, inner product close plus this is the inner product of V W M. The last term will be M inner with W M Wj. The next step, we can take this outside as inner product of V W1 is a scalar. All these inner product are scalars. So I can take this outside as inner product is a function from Cartesian product of the set to the field C, complex field C. So take this outside V W1. I am left with inner product of W1 Wj. Okay. In the second term, I will take V W2 outside, and I will left with W2 Wj. Goes on inner product of V Wj, then I will left with inner product of Wj Wj plus inner product of V Wm, then inner product of Wm Wj. By using this Wi, inner product of Wi, Wj is equal to 0 for I not equal to j, and inner product of Wi, Wi is equal to norm of Wi square. If it is equal to 1, we will get this one. All these inner product are 0. All these inner product are 0 except this term. Except this, all these term are 0. So we will left with this one. Inner product of V, Wj. Inner product of Wj, inner product of Wj. So this is, so in place I will write it this one. This is equal to V Wj norm of Wj square, norm of Wj square as norm of. So in the next step we are writing this one. Okay, since norm of Wj is 1, so in this place I am writing inner product of V, Wj. So this one inner product of V, Wj minus inner product of V, Wj for j ranges from 1 to m is 0. That means x is orthogonal to all Wj's. Okay. Inner product of x, Wj is 0 for all j ranges from 1 to m. That means x is orthogonal to Wj. Now, I'm considering this summation I ranges from 1 to m inner product of b, wi it to be my w. Let w equal to that term. Then put alpha I, this is alpha I equal to inner product of b, wi here. This will become inner sum of I ranges from 1 to m in alpha I w I. So that our equation 1 become x equal to b minus w will be b equal to x plus w. Now inner product of w comma x, w is this element alpha I wi. So inner product of alpha 1 w1 plus alpha 2 w2 plus dot 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 alpha m wm comma x. Then expand this inner product for inner product of first term with x add with inner product of second term with x goes on inner product of last term of the first element with x. Now using the properties of inner product is in place of this I can write this one. This is equal to alpha 1 inner product of w1 x plus alpha 2 inner product of w2 x plus dot 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 plus w alpha m inner product of w m x. So these inner product are my 0. These inner products are 0. This inner product are 0 from here. So inner product of x comma wj is 0. So this inner product of 0. This implies inner product of w comma x is 0. Now norm of b square is inner product of b comma b, and from here b is my x plus w. So put this value w plus inner product of w plus x comma w plus x on expansion. I will get this one as inner product of w comma x is 0. So this is equal to 0. And from orthogonality and orthogonal complement, we know that whenever inner product of w comma x is 0, then trivially inner product of x comma w is 0. We have proved this property in this orthogonality and orthogonal complement lecture. You will check it out. Then we will left with inner product of w comma w plus inner product of x comma x, and we know that inner product of w comma w is norm of w square plus inner product of x comma x is norm of x square, as since both norm of w and since both w and x are non-null vectors, so norm of w and norm of x is greater than equal to 0. Therefore this implies in the next step we can write this is greater than equal to norm of w square. Now norm of w square is equal to inner product of w comma w. So w from the here is my sum of I ranges from 1 to m alpha I w I. So take the inner product of alpha 1 w1 plus alpha 2 w2 plus dot 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 alpha m wm comma alpha 1 w1 plus dot alpha 2 w2 plus dot 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 alpha m wm. Expand this inner product space, that is inner product of first element with the first term of the second element, inner product of plus inner product of first element with the second term of the second element goes on up to inner product of first element with the last term of the second element. So if you expand this inner product space, we will get this one inner product of alpha 1 w1 comma alpha 1 w1 plus alpha 2 w2 alpha 1 w1 goes on up to inner product of alpha m wm alpha 1 w1. If I expand this, I will get this one. From here, by using the properties of inner product space, I can take alpha 1 from this element outside. From this, I will take alpha 1 outside. Then it will be alpha 1 bar. And this will be my inner product of w1 W1 comma W1 plus alpha 2 alpha 1 per inner product of W2 comma W goes on up to alpha m alpha 1 inner product of Wm comma W1 by using, since W1 W2 dot Wm is an orthonormal set, so inner product of Wi comma Wj, if I is not equal to j, then inner product will be 0. And inner product of Wi with Wi is norm of Wi. I'm repeating this thing again and again. So this is equal to, this is my equal to modulus of alpha 1 square. This is inner product. Except this inner product, all other inner product will be 0. So I'm left with this one. And in the next step, it is alpha 1 square norm of, this is W1. Okay, this is W1. This is W1 square. This is equal to my alpha 1 whole square. So I will update. Finally, I will get this one. Finally, I will get this step, that is, this is equal to modulus of alpha 1 square plus modulus of alpha 2 square plus modulus of alpha m square as W1, W2 Wm is an orthonormal set. Using summation notation, I can write this one. This is equal to sum over I ranges from 1 to m modulus of alpha I whole square. Square of modulus of alpha I. From here, my alpha is my inner product of p comma wi. So replace alpha I by inner product of p comma wi. So in next step, it will be summation I ranges from 1 to m square of the modulus of inner product of p comma wi. Then using property of inner product space, this is equal to this one. So in the next step, you can write sum over I ranges from 1 to m square of the modulus of conjugate of inner product of wi comma p. And in case of complex number, if z is a complex number, if z is a complex number, then modulus of z is equal to modulus of z conjugate. So using that property, I can write this one is equal to this one. Okay, this is equal to sum over I ranges from 1 to m square of modulus of inner product of wi comma p. Since norm of w square is equal to sum over I ranges from 1 to m square of modulus of inner product of wi comma p. From here, norm of b square is greater than equal to norm of w square. So this will be less than equal to norm of b square for all b belongs to x. Hence the proof. With this, your linear algebra paper is completed. You should practice lot of questions, solve lot of questions, solve all the solve question of your textbook. Give revision of 3 to 5 year previous year question paper. In case of any problem, any doubt, you can ask me. I will help you. Wish you all the best for your upcoming exam. We will meet again in next semester. With that, I would like to conclude. Thank you.